Here we go. Mallory. 7.
Looks like I tried.
Yeah, I tried. So let's erase what I already tried to look.
Number 7. And everybody's attention. An equation of the line tangent to the graph of y equals 2x plus 3 over 3x minus 2 at the point 1, 5 is. So all this is wanting me to do is what? Find the equation of what? Tangent line. What two things do we need to be able to write the equation of a tangent line? Slope and a point. They gave me the point, so all I need is the slope. Where do we get slope from? Derivative. Thank you. All right, so we need quotient rule. So bottom, derivative of the top, minus the top, derivative of the bottom, and then don't forget the bottom squared. Notice how I put each piece in parentheses. I recommend you do that when you're doing product and when you're doing quotient. Bottom, top. So put the bottom in parentheses, put the top in parentheses. When you're doing product, put the first in parentheses, put the second in parentheses. Put everything in parentheses. That reduces the chance you'll make a mistake. All right, what's next? I could, but since I'm plugging in, I'm going to go ahead and plug in. So we're plugging in the 0.15, so I'm just going to plug in the x value of 1. So this gives me 3 minus 2 times 1, so that's just going to be, or sorry, times 2, so that's going to be 2. And then over here, plug in 1, so that's 2 plus 3 is 5 times 3, 15. On the bottom, plug in 1, so that's just going to be 1. So I end up with negative 13. So what is negative 13? Slope. What does that tell me about this function at the 0.15? Decreasing. Very fast. All right. So I need y minus 5 equals my slope, x minus 1. Now sometimes that might be my answer, but notice what type of form is this called? Standard form. Good.
That's why I was confused. I got the derivative.
So all I have to do is write it in this form. So y minus 5 equals negative 13x plus 13. Move the 13x over. Plus y. Move the 5 over. I have 13x plus y equals 18, which gives me answer choice B. All right. Next question. John Ryan.
So looking at the graph number 13, what constitutes a function not being differentiable?
All right, good question. All right, 13 says the graph of f shown in the figure has a vertical tangent at the point 2, 0 and horizontal tangents at 1, negative 1, and 3, 1. For what values between negative 2 and 4 is f not differentiable? So raise your hand if you can answer John Ryan's question. He said, when you're looking at a graph, what tells you you're not going to be differentiable? Zach?
You don't have a limit, or the limit. I don't know the exact words for it, but you don't have a limit, or there's the gap, other than the vertical tangent line. That's the two I can remember.
There's one more. Hunter, what's the other one?
I was just going to say, because it has to be continuous.
All right, so what Zach was trying to say is it has to be continuous. Then he said vertical tangent line, and Maddie, what's the third? That's the same thing as continuous, or the continuity issues. And the third one is a cusp. So you're looking for where I'm discontinuous, where there's a vertical tangent line, and where there's a cusp. That's going to tell you where you're not differentiable. So obviously at 0, what am I not? I'm not continuous, therefore I'm not differentiable at 0. So my answer has to have a 0 in it. And where's the other spot? 2, because what do I have at 2? Vertical tangent line. Of the 3 that could cause a differentiability issue, which one is not present? There's not a cusp in here. Okay, so in this case, my answer would be D, 0 and 2. Good question. Hunter?
Number 11.
Number 11.
Comes to a point.
Point.
All right, 11. The function g is defined by g of x equals x squared minus bx plus 9, where b is a constant. If the line tangent to the graph of g at x equals negative 2 is parallel to the line that contains those 2 points, what is the value of b? So raise your hand if you can decipher this and tell us what we need to do.
Why?
Abby,
All I know is that the lines need to have the same slope.
say it again.
The lines need to have the same slope.
The lines need to have the same slope. That's a good start. And what tells you that? What's the key word for that?
Parallel.
Parallel. When you see parallel, you should be thinking same slope. Okay? All right. Somebody build off of that. Ethan?
Did you take the derivative of the function?
Take the derivative of the function. So g prime of x equals 2x minus b.
And then plug in negative 2.
Plug in negative 2. So g prime of negative 2 equals negative 4 minus b. All right, we're piecing it together.
You bring the deal.
Nope. All right, Milani, speak up.
Find the slope from the point.
All right, so I want to be parallel to the line that goes through these 2 points. If I've got 2 points, what can I find? Slope. So, excuse me. 5 minus negative 1, 4 minus 1, 6 over 3, which means my slope has to be 2.
So, yeah, you said
Now I set the 2 things equal. I need to set this equal to that. So negative 4 minus b equals 2. Negative b equals 6. b equals negative 6. Very good. So let's pause and make sure we can digest this problem.
Why did you set the slope equal to negative 4 minus b?
All right, can somebody answer that question? Why did I set the slope equal to negative 4 minus b? Roshan?
The derivative is the equation for that. slope of the tangent line.
Right, remember you get slope of the tangent line from the derivative. Here's my derivative with that x value plugged in. We want it to be parallel, so it's got to equal this. So I set the derivative equal to 2 and solve.
So the slope that we found is of the, it isn't the slope of the original equation, it's the slope of the other line.
It's the slope of this thing at that point.
Okay. So you're saying that the line, that line contains those 2 points?
No,
The 1 and negative 1?
does not contain those 2 points.
Okay.
It's saying a line that is parallel to the tangent line of this contains those 2 points. So the line I'm trying to be parallel to goes through those points. That does not go through. All right, Ivan and Ryan, I need you guys to quit talking.
Thank you.
Yeah.
Is vertical tangent line number over 0?
Number over 0.
Horizontal is the opposite?
No.
No.
Or
Oh, that's horizontal.
yes, horizontal is the opposite. Okay, you have 0 over number. All right. Anybody, any other questions on this one?
Number 10.
Number 10. Yes, this is that prop.
That's all you guys keep messing up.
All right, so what's the first thing before you take the derivative that I want you to do with this problem?
Move the
Put the
4.
4 over the.
Rewrite it. We need to understand that we're dealing with cotangent of 5x, that whole thing to the 4th power. And then from there, it's just the chain rule. So bring the 4 down, inside stays the same. New exponent is 3. Derivative of cotangent is negative cosecant squared. Inside stays the same. Derivative of the inside. Clean it up a little bit. That's what we're looking for. All right. What else? 9. All right, determine the points, if any, at which the graph of the function has a vertical tangent line. So what does that mean to me? What has to be a number over 0? The derivative needs to be a number over 0. So I need to take the derivative. So that's 1/3, 2x plus 5, negative 2/3. Don't forget to take the derivative of the inside. So we end up with y prime equals 2 over 3, 2x plus 5 to the 2/3. And we want that to produce an undefined slope. The only way that produces an undefined slope is if what happens? Bottom has to be 0. So I set the bottom equal to 0. Alright, so the 3 is going to go away. 2/3 is going to go away. Subtract the 5. And divide. That's going to give me a vertical slope. Notice though the problem says point or points. So what do I not have yet? I need a y value. And we should know by now we get y values from plug it into the original. Okay, so if I plug negative 5 over 2 in here, 2's are going to cancel. Negative 5 plus 5 is 0. So my point is negative 5/2, 0.
Couldn't you do it? Could you write 3 to the cube root of 2x plus 5 squared?
Yes, same thing.
Well, when you're solving that, wouldn't you get square root?
Are you talking about up here?
No, when you set it equal to 0, you wrote it as 3.
Right.
So you divide by 0 and then you cube root.
I divide by the 3.
And you get cube root.
Cube root 0, square root 0. Doesn't matter what you do to 0, 0 is always going to be 0. Abby?
I did it and like I took the derivative and everything, but I left it as 2/3 times 2x plus 5 to the negative 2/3, and I just set that whole thing equal to 0. Is that wrong or just like?
You got the right answer, but you were probably thinking about it incorrectly.
Okay.
All right, one more. All right, let's choose wisely. But again, I'll put the rest of them. Make a video tonight, or right after this class, actually.
Wait. 14.
Let me see. What does 5 look like? 5's just product rule.
I say 6 or 14.
Let's do 12. You guys continue to screw up 12, even though it's like the easiest problem that we do.
That's what you just do. Yeah, son. I got
Haley? Never mind.
Is this just taking I can just take cosine of mine?
How is it negative?
Okay, listen. This is what I
There's two different ways. There's two different ways you guys can do it.
Can you do it this way?
So you get rid of the pi over 4 plus 8. So x is there. Take the derivative and plug the pi over 4 back. Alright, I'm going to show you the two ways you know how to do it now. First way is what Haley was saying is you need to recognize this as the limit of the difference quotient. Okay? So, once you recognize that, we need to identify, bless you, identify what f of x is. You can look at either one of these spots, okay, to get f of x. You just take out what's on the inside on either spot and put an x in it, and you found f of x. So what is f of x in this case? Cosine of x. That's step one. Now, sometimes there'll be a number over here, so you can't use the right side. Just go to the left, take the parentheses out, put an x in, you got your f of x. All right, what's next? Find the derivative. So negative sine of x. And then my last step,
Plug in.
yeah, whatever value is here or here, plug it in. Okay, and we should know sine of pi over 4, square root of 2 over 2. You stick the negative in front of it. We get E as the answer. Now, what's the other way I can do it? What's the other way I can do this problem? Either. Say it again. No, you can't use alternate form of derivative on this one. You can use L'Hopital. So I could use L'Hopital.
I was gonna say I didn't put cosine x. I put cosine of pi over 4, and then just went down to.
It needs to be x. I mean, if it's multiple choice and it's the AP test, they're not going to look at your work. But you need to be doing it correctly.